Very good morning to everyone. Welcome back to Architect Live Talk 2021. This time around, we're going to have a part two of a roofing system for aviation industry. I think for the first part one, I think everybody has seen that we'll talk about the terminal. What is the roofing requirement for the terminal? But is in any airport in the world, you do have ancillary building or supporting building. Either is a catering buildings, fire fighters building, and in this case, we're going to talk about hangars, which is one of the most important building to make sure that all the aircraft fly in a good manner. I'm not going to talk alone today. Again, I have my sidekick or my wingman, in this case, wing lady, Miss Ok Ling will come later to talk about the material, which is actually a case study, a real case study of the particular building mass A380 hangar or hangar 6, we call it in KLIA, just to see what is the performance of material that have been used since the day that we installed until, if I'm not wrong, about 12 years later. Then we see how it performed, and some of information that's very useful to everyone who to select the material for this particular building. Okay, let's start with my first presentation, my first page of my presentations. I think there are a few challenges or requirement when we did with this particular building. Actually, the first one was the size of the building. When you have a building which is a huge, flat and long roof, there's a lot of consideration to be considered while selecting the material and also the profile for the particular building. The other thing we're going to touch here is actually the construction challenge. So when things are big, the bigger they are, the more problems or more difficult they are. But we're going to share during that particular time what are the construction challenge that we have. And the third one, again, when you have a roof that is big, huge, long, flat, and living in this region, which is we have a very heavy rainfall, and lately the rainfall has been very, very different from the past 10 years. We will talk about rainfall intensity, which is very important when selecting a roof profile, and again, material, because rainfall can do a lot of things to your paint system or even to your material. And the last but not least, we're going to talk about roof in open area consideration. What are the things that you need to consider when you have a big area and a lot of opening, and how to consider all these parameters when you design a particular building. All right, quickly introduction. Our scope of work, United Season or the brand of Kawa, our scope of work actually is to supply and install envelope for the building, consists of the roof skylight, which is also acts as ventilators, and also wall cladding and a rainwater drainage system, which is the gutters and also the piping. Just to let you know that the project site actually is next to Mars Hangar 5. Whoever been flying to in KLIA, if I'm not wrong, if you land from runway R right 32, you will see the hangars is on your right side of the aircraft. Actually, it's within the mass complex KLIA, which is consists of a lot of building, which is I said just now, the ancillary or the supporting building in mass complex KLIA, Sepang. All right. The building for the hangar building actually is meant for MRO. It's actually a short form for maintenance, repair, and overhaul all the aircraft for MAS. And I believe they also do a maintenance for other airlines also in this case. Now, brief description of the covered hangar building. So the hangar building actually is a clear column free space, which is 230 meter span, uh, columnless, and 100 meter deep, which is how long the building from front to the end. And then actually it has a 32 meter minimum clear height, and also the highest point of the roof actually not exceeding 45 meter from the ground. If anybody one could imagine 45 meter from the ground, actually 3 meter, every 3 meter floor actually 10 story, talking about more than 15 story height. That's to see how high the building are at the end. Actually, it's designed to accommodate various aircraft maintenance arrangement, but in this case, we call it A380 hangar because it's purposely to accommodate for two Airbus A380 and one smaller aircraft simultaneously inside the building. If you can look at the building, actually you can side by side A380 aircraft on the left and right, and one in the center were probably A330, which is a smaller one. And I believe some of you guys flown in A380. You should know how big is the aircraft, and you should see the hangar, which is much bigger. Now, a few production challenge that we have during that installation or production of the product inside. You imagine that the roof length, actually each of the roof length actually at the length of 114 meters, and it has to be bundled and distributed evenly over the entire hangar roof. I will explain you why that we said it evenly over the entire hangar roof later in some photos that I will show you in a few slides later. Imagine that each bundles are about 2.11 metric ton. We can only install the roof Kawa R650 at the roof level at 32 meter to 45 meter after the final roof checking. Yep, and I will explain that later why this is mentioned in it. So we have about 25 to 28 installer per team at one time to just to make sure that we finish on time. For the safety reason, one time and one team of roofer are allowed to at the roof because for monitoring and also to make sure that loadings has been controlled. Of course, the claddings, all the cladding has been erected by a scaffolding all around the building just for the Kawa R600 installation on the cladding. Right. As I said just now, originally that if we want to do a road forming on site, and most of the time on site road forming either at the ground at the roof level. In this case, because the roof level are at 45-meter height at the highest point, so we can't do a staging at 45 meter. What happened is actually they have designed a platform, or we actually a temporary working staging at 40 meter height, and then we produce the material, and then again, as said before, is distribute evenly before we can jack up to the final height of 45 meter or 32 meter to the point. Then only then it been installed. Yeah, this is an example of how the platform has been done at 40-meter height, still on a very high 14 meters. So this is when the production has been done. There is a lot of safety consideration. If you look, there's a proper platform, proper rollers, and proper people to look at to stay at one side to make sure things are being organized properly at the site. As you can see that at the point of the operators, you can even see the last people at the end of the roof. Actually, that's how long is the roof, actually 114 meters. Right, everybody should understand it's not easy to work with this kind of length. This is what I said just now. If you can see that it was distributed uh, evenly, just to make sure that the loading is not overload at one point of the columns, or one part of the structures. So it's not the only reason that has been distributed evenly. There's another reason. I will show it in the next slide. Why that it has to be distributed evenly before we can install the roof onto the final structure. Please note the design for this particular hangars, in order for you to save a lot of structures. In a normal case, normal design structures, you're going to talk about 1.2 to 1.5 per lane span. If you notice by looking at the photos, if you look at the plywood that been as a part of the working platform, so the plywood actually normally at 1.2. If you notice that the structure from one plywood to the other plywood, you have another gap actually at 2.44 meter. In other way, you should be able to save a purlin almost 30% of your purlin usage in the design. When you have the, you can you're spanning your purlin at that length or that distance center to center. The reason that you can do that is actually because Kawa Locksim R650, that in this case we are using clean color bond XPD, color tinted gray if I'm not wrong, that it has a 98 rib height and also a 650 width profile, which is a concealed facing system. When we have a 98 0.5, then you're talking about bold and deep corrugation. It makes it extremely strong roof profile. That's why you can actually at thickness at 0.6. In this case, you actually can spend 3 meter if you want, but in this case they just stop at 2.44. And because of that high rib profile, That is very important when you design a very long roof with a very low pitch at 3 degree, that you can go as low as 1 degree, just to make sure again, what I said before, the rainfall intensity. This is another consideration you have to consider when selecting a material or profile for your particular building. Of course, for the cladding, is a very simple deep corrugation R600 building profile, also including carbon XPD. The reason that the design of being selected, or the profile has been selected for the wall, is for a simple reason. If you have a big building and you have a very low, shallow profile, then the building just look basically flat. It doesn't show the design integration in terms of to see how strong is the building at 45-meter height kind of cladding. So this is where the bold corrugation, deep corrugation, which is have a bold and deep, can actually accentuate how the architectural looks at the end when the project is completed. Yeah. Right. This is this is where, as I said, why that we actually distribute the material before we start installing, because the design of these hangars, actually they have a lot of rich ventilators. It's for ventilation purposes, as such a big building, a big area. So in order, if that we did not distribute the material before we install the rich ventilator, in order for you to go one crash of that particular ventilator at a material at 1.2 metric ton per piece, it's going to be a lot of problem, and it's going to be very slow. So the idea is actually coordination is very important, is distribute evenly, and when come to the ventilators, it does not obstruct any ventilator installation as at the end of the day. It's very important when you have a long roof and a lot of rich ventilators, a lot of skylights probably, or even a smoke screen to some building. Yeah. Right. So this is when it's completed. If you notice that I showed just now the ridge ventilator, just to mention that ridge ventilators, the designers have selected to use skylight material, which is fiberglass reinforced plastic, or we call it FRP, just to make sure that they don't have to use a lot of power to generate light inside the building. So this system actually have a lot of natural lighting inside the building in normal daylights. They actually use less power into to put the lights on. And again, when come to ridge ventilator that long, actually it actually create a lot of airflow or air change inside the building when it's hot, where the hot air, as we know, that go up. I think the other part that is very important, where they have a lot of ventilator, because of one of fire hazards, where the smoke supposed to able to disperse from the building as fast as possible. So that's why if you see they have a lot of ventilators, or rich ventilators in this case, in this particular building. So this is when it's completed, but if you look at the on the left hand photos, actually this building at this moment having 2-story office. They actually plan to have a 5-story office, so it will come later when things are required. I think believe they're going to continue up the construction of that particular office building. At this moment they're still at 2-story building. Yeah. Right. So this is the thing that I've said about rainfall intensity. In Unison, or in Kawa roofing, we actually have the ability to give you advice when you have a long roof. How do you work with long roof? How you calculate things? You make sure things are profile have been selected properly. I put an example that we have this so-called determination of water flow depth in any profile that we have, to make sure that from one end, before it disperses to the gutters, make sure that the water height, or the level of water that accumulate from top to before it reach the eave, does not seep over the so-called side joints. This is very important. Some people don't realize this, but you have to understand this is how it works. Okay, I put an example that in this case of hangers, they're gonna have we create we have take a consideration of rainfall at 350 mm per hour, that you have a groove gradient at 3 degree, and as you know, as a length of roof 115 meters. I think there are many formula to use. I think most engineers they use about hydraulic calculation. In this case, you have either Gunkelett-Coulter formula, or you can there's also cheesy formula, and then some hydraulic they use Manning as part of the calculation. But in this case, we have make we are going to use we use actually a very more stringent calculation or formula that to get these figures. Okay, as I said, we have used 350 mm per hour rainfall, 3 degree, 115 length. Then, after you have put in the formula of the consideration, the water flow, the resistance, everything, actually you can actually determine what is the highest point of depth of water towards the end of the roof. In this case, after put all the formulation, everything, actually is actually look at the rate at the back there. The summary that the depth of water flow along the valley or through the roofing actually is maximum at 37 mm in height. Where again, as I said, even the rib height of Kawa R650 is 98.5, but the side lap of height of Kawa R650 is only 80 mm. But in this case, if you have 37 water level height maximum, and your profile your side lap is 80, you are very much safe. It's not even, it's only used 50% of the capacity of that particular roof profile. It can, you know, even though, I mean, if you drop another degree, or even you increase the 400 mm per hour, it still be safe to use this profile at this length, at this angle. You see, at gradient 3 degree, we will say that water will not overflow through the side of the side laps roofing. I'll just put another example. If it's same criteria that we put in our this rainfall at 300 mm per hour, 3 degree, this is one of our profile, we call it clip system. I as a being and roofing a manufacturer, that many times that we seen that everybody thought roof clip system, in this case our 6670, can do a lot of magic, but there is a limitation. Once you have certain length, a certain angle, you are not advised to use certain profile that not be suitable for that particular design. I just put an example, just, you know, out of the craziness, you're going to use a clip lock in this kind of design. So you the same parameter, 350 mm per hour, 3 degrees at 115 length. So what will happen is the depth of the water flow along the valley towards the end is actually 23.5 mm in height. And the side lap of our Kawa 670, even though the rib height is 41, people always confuse the rib height and the side lap. The rib height, yes, you can have a rib height at 50, whatever, but the most important thing is your side lap height. Once your side lap height is actually over, then you're going to start leak. So in this case, as I said, the side lap of Kawa 670 profile is actually only 17 mm. Again, I repeat, even though the profile height is 41, the side lap is only 17. So with the rainfall of 350 mm per hour, falling on a roof sheet is 150 meter long with a gradient slope of 3 degree, you can see that the water is 23 in height, and the profile side lap only 17. It is over, meaning to say that you're going to have problem with side lap leaking. It is not but about lapping and lap. Like, every your side lap, all your side lap will have leak, which is the water which is over the so-called the side lap. This is not good. So to some extent, in order to compensate this thing, either you increase your height or your angle from three maybe to 5 to 6, you need to calculate. But when you have a building that 230 meter abreast, increasing another angle, another degrees of your structure will cost you a lot of extra cost in terms of structure. I think the structural consultant will be able to advise on this, because we are not. But as what I know, that once you start increasing your angle, you are going to start to increase your cost. So that's why most of big building, 100 meter or under 80 meter and above, you're going to start work with 3 degree, 2 degree, or 1 degree. Then the importance of profile is very critical in this case of design. So this is when we talk about rainfall intensity. I think maybe a month ago, if I'm not wrong, I think it has been recorded that rain has gone to 420 to 430 30 mm per hour. Imagine that in some building that you are unable to cater for the rainfall that you're gonna get at this moment. Climate change, whatever you say, this is climate change nowadays. All right. So the last that I would say, this is a open area, wide opening building. I think as you can see, hangar is going to have big opening. From this is if you look from the on the left side or the right side point of view, you're gonna be have an air side where you're gonna have a lot of wind coming through the building. So what will happen? This will create. I just simulate a bit here. If your wind came from this side, you imagine that there's a lot of wind coming in, then it will still continue going in, but when it hit the wall, what will happen is it will go up. This is in our industry, we call it a negative pressure. It would actually create where your roof can actually blown away if the wind is very strong. Um, Even though in Malaysia we don't really have really strong wind, what we do have sometimes what we call it freak storm, and it came over with that speed, hit the wall and goes up. That's where your roof will be blown off. So because of that, one of the reason that to choose a correct profile in this case, because of big opening, the 650, just to share that 650 actually originate from Japan. Actually is supposed to able to withstand a typhoon kind of wind speed situation. So imagine if you have a simple clip fixing there, depending on your clip, without seaming or anything, that when this kind of wind blow, you imagine you keep on coming, you have a freak storm, then you have a big issue on this case. Okay, because of that, Unison, we have sent our product for what we call it a negative pressure report. So this negative pressure report was done quite way back in I think in 2011. Before that we use actually BS 5950 part 6 under what we call it the structural use of steel works in building, or part 6 we call it a code of practice for design light gauge profile sheeting section 7. So when we do the testing, actually, this testing actually in 2003, proud to say that we are involved. Cirium had come out with their own test method under MS2 2523 2013. That's how to test. This has been done way before that this standard has been created. So I just want to share. Imagine at this Kawa 650 at the same thickness at 0.6 mm BMT for this negative pressure you're putting in a hydraulic machine, then you put a force on it until the system actually dislodge from the clip. When we did the testing, we actually push a bit more than what we can do. Actually, if the test report actually, if from the test report actually, the purlin spacing actually at 3 meter instead of 2.44 just now we have on in the case of hangers. So at 3 meter, surprisingly, I won't say surprising that the good thing is actually, imagine that the metals roofing actually dislodged from the system at the load of 13,200 Newton, which is in a normal case, in a common understanding, it almost about 13 ton of pressure before the things actually dislodge. That to show that how strong are the pressure that can be taken by R650 in this case of wind speed. Yeah. Right. So this is how the sample looks like. I think the figure one show the during testing before the load is being put. And even though that after 13,200 newtons of force have been put, only two section actually for the roof actually dislodged. The other one is still intact with the clips, the so-called the connectors, without any problems. Yeah, see, that is the most important thing that you have to consider when you have an open building concept in your design. All right. So as I said from earlier of my slide, I think take it this A380 is part of the reference when you have a building which is a very long length with a very low pitch. then all these consideration must be taken care of. You know, you don't simply that, oh, I want to have a very flat roof, but you're going to have a wrong profile, you're going to have a lot of issues. I just want to share some of project that we have done that have this similar issue. So this is, as I said, we have a hangar 5 and a hangar 6. So at 150 meter, I can't remember hangar 5 how much, but hangar 5 was slightly shorter, maybe about 100, 110 or something like that. Okay. The other one, this is a Proton City body shop at the time in Perak. I think it's way back in 2003 or 2004. The roof line actually 160 meter, and the angle actually 2-degree pitch, just to make sure that 2-degree virtually almost flat. And you're talking about the flow of water can be very slow, and the roof design or roof profile that you select must be able to cater for the amount of water at 160 meter. Is have a lot of water in this case. Yeah. Another example that you have this, we installed Panasonic Energy Malaysia in Kulim High Tech Kedah. So the roof line is about 94 meter. Correctly is about 3-degree. Technically they want it to be lower, but I think the engineers just want to play safe. They put at 3 degrees. So it at 94 meter length in one piece. Again, is I think if I'm not wrong, is about 32,000 square meters. So it worked perfectly until now. Another example that I would like to show, this is Honda assembly plant. I think anybody goes use Honda car. This is where their paint line. You see, all your Honda will paint over here in Honda Melaka. So the roof line is about 126 meter length, and it's at 3-degree pitch. So this is among the longest and most difficult building in all of Honda plant in Melaka. Another one was Shimadzu, Japan. Japan contractor love deep corrugation to some extent. But anyway, the design for this particular building actually is a mono pitch roof. So it's only angled at one side at 86 meter at 3-degree pitch. So again, the consideration is water and your angle. So it is very important in this case. So you can see that from far you can see the bold line of that particular roof up there. And the last, probably this is the last, this is a Daihatsu transmission plant in Sindayan. If you could see that all are virtually flat as possible, 3-degree. Probably when I say 3-degree, the design is 3-degree. In many cases, some of the structure people, they were slightly off by 0.5 or 1 degree, it become 2-degree, and the roof had to perform even at 2 degrees in this case. Yep. So I end my presentation in a say safe flying, everyone. I think the hangar is where MRO is being done. Hopefully they do it properly so everyone can fly safely to any destination as I. So with that slide, I would like to invite my sidekick or my wingman or wing lady today, Miss Sok Ling, to give us in-depth what you call it findings after the case study of A380 Hangar in terms of their material, which is super fantastic material that we have worked since 1994 in my case. So Ling, without further ado, I'll invite you to have the screen.
Thanks, Daddy. And hi, everyone. My name is Sotlin. I'm the Technical Marketing Engineer from NS BlueScope Malaysia. So today I will be sharing a case study on the Mars A380 Hangar after 12 years of performance. So I will be sharing a very basic introductions on the material itself, and then it will be followed by how does the material performs after 12 years. And I will also take the opportunity to share some of the learning during this case study visit. So without further delay, let's get started. So this building is actually the Mars A380 Hangar, which is also known as a Mars Hangar number 6, because this is the 6th hangar to be built in KLIA Sepang. And then the material used for the external cladding applications, like the roof and also the wall, is actually using 0.6 mm BMT clean carbon SPD steel. And the color itself is actually the tinted gray color. Like what you can see over here is the light gray color shade. And the roofing profile is using the Kawa R650 Loxing Type 2. For the walling profile, it is Kawa R600. And this building is completed in year 2007, December. And when we went back to conduct the case study visit, it's 12 years apart, which is fall in December 2019. And this building, I would say, is one of the longest single span hangar, which having the 230-meter clear span entrance. It also means that there's no column in between the buildings to allow the aeroplanes to park inside the hangar without any issues. And the building width is actually about 100-meter length. Just imagine you are on the running track of 100-meter length. This is how huge the building is. And it is also having a clear height of 42-meter height. And this is basically to show you the close-up on how actually the roof profiles look like. Because from far, we can't really identify the roof panels. So I put out a close-up shots for this Kawa R650 Loxing profiles. And for the wall cladding, it is Kawa R600. This two profile is actually a deep corrugated profile. And the material itself to raw form into these two deep corrugated profile is actually Carbon SPD. And this is the cross section of Carbon SPD steel. And why they're selecting Carbon SPD steel, but not other material else? Because for this hangar building, they have the expectation towards the durability of the material itself. So when we talk about the material durability for the coated steel, we'll be looking into the corrosion resistant performance. And for Carbon SPD steel, it is using the zinc as a steel substrate. And BlueScope, we have a very strong R&D teams to always study and conduct a lot of testing to ensure our materials are performance in the long run. And this is one of the exposure tests which are managed by our R&D teams based in Australia, whereby they are exposing the zinc materials versus the other materials over the very severe marine environment for 12 over years. And this is the result that we obtain. For zinc we do not notice any significant kind of the red rusting corrosions. However, for the other materials like galvanized steel, it shows the sample is badly corroded until the perforations. Another reason why Carbon SPD have been selected to be one of the materials for this mass hangar project, because for Carbon SPD, it able to deliver the better in terms of the color durability of performance. Do you know that SPD is actually stand for exterior paint durability, because it is using the PVDF paint system. And PVDF paint system is well known as one of the paint system which are able to deliver the long-lasting color performance. But please be mindful that not all the PVDF paints will be equally were able to provide the equal color performance, like the cases that I'm showing over here. All this panel is actually the PVDF paint, but only one PVDF paint were able to optimize its color durability performance by setting at 70% of PVDF, 30% of acrylic resin. For the rest of the panels, even though it is with using the PVDF paint, but without the optimized paint formulations, it is unable to deliver the color performance as good as the optimized versions. So in order for you to check with your suppliers whether how good the PVDF paint able to perform, you can try to ask them to show you the proven track record of their past projects. Like what I'm doing here today, I'm going to showcase to you the actual Carbon SPD steel after 12 years. I think those proven track record will be much more convincing comparing to somebody come to you and presented the numbers on the paper to you. The third reason why carbon SPD has been chosen is because across all the carbon steel, it comes with the clean technology, or in other words, we call it as self-cleansing ability. So how does this clean technology works? It's actually we add on additional layer on top of the paint layer, paint surface, so that the dirt particles, it won't be bond or stick to the surface like what you can see over the figure B here. It will only a temporary sitting on top of the cladding surface like figure A here. But for this clean technology, it requires the assistance of the rainwater, because without the rainwater, those dirt particles, it will still temporarily sitting on top of the cladding surface. So once the rainwater comes, it will flush out all the dirt particles away. This is how it works. So the image on the right here is actually to demonstrate to you the difference in between the dirt pickup performance with clean layer and without the clean layer. It is very obvious in terms of the pickup performance. Okay, now we are moving towards the most interesting part, the material performance after 12 years for this mast hanger building. First of all, I will be featuring the roof appearance. And for your information, this mast hanger is just located next to the airport runway. As you can see in the photos over here, this is the airport runway. And most often people might perceive that it could be having a lot of the sand or even the dust or dirt particles to be deposited on top of the roof sections. But during our case study visit, which is back in December 2019, from the old photos, we do not notice any dust or even the dirt deposition on top of the roof surface. And it also proved that our clean technology does work for carbon SPD steel. And also for these old photos, the color, there is no color variance among all the roofing panels, like what you can see over here. And there's no sign of the red rusting corrosions as well. By looking over at the wall sections, similar observations, like what we noticed over the roof sections, there's, the color is very even for all the wall cladding panels over here. And we do not notice the very obvious or the significant kind of the pickup or the dirt deposition or water streak mark over the wall cladding sections. And if I am the building owner for these buildings, I will be very happy to see my buildings after 12 years to give me this kind of the result, because it still looks like it's newly installed kind of the buildings for me. And we also brought over our originals, the tinted gray color panels, which normally is one of our retained samples. Then we just put this original sample on top of the roof profile itself. We compare it in both paint and also the wet area, like what you can see over here. And from this observation, I can conclude that the color change is very, very minimal. Same goes to the wall sections. We also comparing our tinted gray original panels over the web sections of our wall cladding profiles. So over here is a similar observation like what we noticed over the roof sections. It's a very minimal kind of the color difference. Another aspect that normally we will be looking at would be the cut edges, because cut edges will be another crucial part that normally people will have the concern on it, because it is one of the opening area for all the orthodox steel materials. And we have inspected almost all the cut edges area, either the side lapping, the roof edge cut edges, or even like ridge capping edges, and etc. And from our observation, we do not notice a very significant kind of the red rusting corrosions after 12 years. And we even brought over our micrometer gauge to perform the simple thickness measurement as well. So for this material, it's actually we supply using the 0.6 mm BMT clean carbon steel. So theoretically, we will be able to obtain the after painted thickness minimally 0.68. And during our measurements in December 2019, the result is actually 0.693. So I can say that the erosion of the material itself also can consider very, very minimal. And why BMT is so important to be specified in any roof specifications documents, for example, like the BQ documents. Because if we are specifying insufficient BMT for your roofing profiles, then you tend to see this kind of the failure mode, whereby the ridge could be easily dented. And BMT is very crucial, especially for the deep corrugated profile, like the profile that we use for this mast hanger project. And it will also impose another risk of roof collapse if the thickness that you specify is insufficient to cater your or to match your roofing profiles. So do always consult the raw former expert like United Season in your roofing or walling specification activities. And for BlueScope, we have all the branding tags for all the materials that is manufactured by BlueScope. So in the branding tags itself, we will be capturing the product brands, for example, like Carbon SPD steel. And then we'll be also capturing this is the time and also the date when it being manufactured. And the number 11 behind is actually indicating NS BlueScope Malaysia manufacturing site. So during our case study with 6, we are also able to identify and also to trace the roof material is actually using the Carbon SPD steel materials. So from here, we can see that this is SPD steel. And it is manufactured in the morning, which is 10:58 in the morning, and on 28th of April 2007. And the number 11 behind indicating NS BlueScope Malaysia manufacturing site. Now it comes to some key learning sharing during the case study visit. So one of the quick practice that I would like to share is this is one of the roof detailings whereby in the roof detailing itself for Kawa R650 log seam, they do mention that need to introduce this end stop to cover off all the contact point between the ridge capping with the roofing profiles. This with the introduction of this end stop, it will able to prevent the possibility of the leakages from the external towards the inner buildings. So I do believe not all the installer will install this kind of the end stop. So I would say this project, they are considered quite one of the good installer to practice based on the roof detailing provided by the raw former expert, which is United Season. And during the building hangover process, there will be some site inspection to basically to go through all the due diligence check before the official hangover activities to ensure that the building is in the good conditions and free from any defect before the building has been handed over to the building owner. So most often we do not notice all this kind of the, for example, like this is actually a soft staining during the site inspection before the handover process. So I do believe that this soft staining could be potentially due to the additional work on top of the roof surface after the handover process. Because, for example, like this steel roof, during the roof installation, they do not require all this kind of the steel roof. So it could be due to the additional work after the handover process. And I do believe they have performed some cutting process which is related to the steel materials, which yield a lot of the burr and also the soft stain or leak. So what is the remedy action if you notice all this kind of the soft stain? You can always try to seek your manufacturer or the supplier's assistance to assist you on what are the remedy actions for this soft staining. So for BlueScope, we have one technical blurting, which is technical blurting number 5 which is talking about how to remove the mild swat stain. So inside this technical bulletin, it is advisable to use a mild household detergents paired up with the scalp bride or even the sponge or cloaks, and then you can flush out it with the water. So the photos on top is actually to demonstrate to you how the cleaning process can be done. So before washing, we do notice all this kind of the minor soft stain on the roof surface. So we wash it using the mild household detergents together with the scalp bride. And then we let it dry off, and then the mild soft stain is completely removed afterwards. However, there are some swat stain which we classify as a stubborn swat stain, because we do believe that this swat stain is already there for more than 5 years, which is already bonded towards the roofing materials. And then even we perform the cleaning process by using the mild household detergents, we still have some remainder rust, which we classify as a stubborn rust, because it is all this rust is already embedded or bonded to the roof surface itself. So it is unable to remove. So to remember, whenever you encounter the swat stain, please conduct the remedy action immediately to remove it off, to prevent all these stubborn swat stain to be remain on the roof surface. And in this same technical bulletin, it also advises what are the proper tools to be used for all these cleaning activities. So we are recommending using the scalp bride or sponge or even the cloaks to do all these cleaning activities. Please do not use any steel wool alike materials, because it will damage the paint surface. Just put into the scenario like when you perform the car washing, we won't be using any steel wool alike materials to do any cleaning on our car, because we all know that it will damage the paint layer of the car. So same theory apply over the roof, because for the roof, it's actually also having a layer of paint coating. So if you're using any steel wool alike materials, it will damage the paint layer. Another learning from the case study we see is actually the scratches. And I think those scratches is quite difficult to be avoided if there's any additional work on top of the roof surface. So for BlueScope, we are also having a technical bulletin, which is technical bulletin number 10, to guide you on how to manage whenever you see the scratches. So we classify the scratches into the two types. One is actually the minor scratch, another one is actually the severe scratches. And how do we define minor scratches? We are benchmarking ending the scrap width that is lower than 2 mm scrap width, or is it something like the hairline kind of the scratches? Those we are classified under the minor scratch damage, which we will recommend to leave it alone, because it won't be impacting so much towards the material's performance. However, if you notice any scrap width, which is more than 2 mm scrap width, and then there are some of the metallic alloy layer which has been completely removed due to the very severe kind of the scratch damage, then we will be recommending to replace those affected sheets. And why we are benchmarking 2 mm as our guideline? Because we have conducted a lot of the study towards the scrap width. For example, like what you can see over here is 0.25, 0.5, 0.75, and even 1 mm. And then we conduct up to 2 mm. So from our study, from 2 mm onwards, it will start to showing the red rusting corrosions. So we are benchmarking any scrap width that shouldn't exceed anything higher than 2 mm scrap width. Then for those, we are classified as a minor scratches. Another learning from this case study is about the overpainting. And why BlueScope we do not encourage any overpainting activities to be conducted on top of the BlueScope pre-painted steel, for example, like Carbon SPD. Like what you can see over here, it's very obvious for us to identify. This is actually the overpaint surface, because those overpainting activities or overpaint surface, it will impose the risk of uneven color performance. That's the reason why we can easily identify that this is actually overpaint surface. And we use our fingertip just to rub off over the overpaint surface. And then from here, you can see that we are able to pick up a lot of the chalk powder from the overpaint surface. This is due to the color have been faded. And we use another fingertip to rub off the Carbon SPD surface. It only pick up the minor dirt. And these are the photos, basically to show you the consequences of the overpainting activities on top of the pre-painted coated steel. You won't be seeing the impact within 1 or 2 years time, but after 5 years, it will definitely showing a very obvious in terms of the uneven color performance. So try to avoid any overpainting activities. Last but not least, this is one of the other materials kind of the performance. I have the opportunity to look into like the other cladding material performance. This is actually referring to the mast hanger number 5. So from here, during our case study visit back in 2019, we noticed that this is inconsistent kind of the corrosion resistant performance. For this is actually the canopy roof. This photo is actually taken over this corner. From here, you can see that the canopy roof is showing the red rusting corrosion. However, for the lower roof, it doesn't. It's still performing. So it could be due to the different type of the material have been used or different type of the coating class. So generally in Malaysia market, there are 2 types of the metallic coated steel that is available in Malaysia. It could be AZ type or Z type. The main differentiation between AZ versus the Z type is about the coating compositions, meaning that the coating composition of the metallic coating layer. So for AZ, it has 2 alphabets here. A is stand for aluminum, Z is stand for zinc. So it's a mixture of aluminum and zinc. For Z type, it is approximately 100% of zinc. When we want to do the comparison, we will look into the corrosion resistant performance, because the objective of adding in an additional metallic layer of coating is to prolong the lifespan of the steel, to improve the corrosion resistant performance. So these 2 photos is actually we captures under the microscopic view. We want to see what actually happens to the metallic coated steel for AZ type versus the Z type. So initially, there's 1 layer of zinc coating on top of the best steel here. But this photo is taken after the panel being exposed. So the zinc will sacrifice off for oxidation process, because oxidation process will happen from time to time. So the zinc will sacrifice off to react with oxygen. And then once the zinc has been oxidized or sacrificed off, it will start to create the gap like this one, because it got nothing left. It will start to create a gap and allowing the environment to attack the best steel directly, which enhance the corrosion to happen afterward. For AZ type, the black spot over here is actually the zinc content which already been oxidized, because the zinc will still act as a sacrificial protections. But for AZ type, it still has the remainder of aluminum, which are those gray colors, which is the remainder of the aluminum, which still act as a barrier protections. That's the reason why in terms of corrosion resistant performance, AZ type tends to perform better compared to Z type. And these are the accelerated corrosion tests. We are using the pre-painted AZ type versus the pre-painted Z type over here for circuit corrosion test after 2,000 hours. So for pre-painted Z type, we tend to see there is a sign of the rate-rusting corrosion for all the opening area, such as the cut edges and also the scrap line. However, for the pre-painted exact type, we do notice there is sign of reactions happening over the cut edges, but we haven't seen any red rusting corrosion yet. So that's all about my sharing for today. So in short, for my case study visit for this mast hanger after 12 years, it can come into a few summary points in terms of the profiles, like Kawa R650 and Kawa R600 profiles. I would say it is still functionable as it's first installed. It's still able to channel out all the water effectively, whereby we do not notice any sign of water ponding and etc. So in terms of the material wise, I would say the materials will be tied together with the profiles. So once the profile were able to perform, then the materials were also able to perform equally. So in terms of the summary, in terms of the materials performance, by looking towards the corrosion of performance, there is no sign of a red rusting corrosion have been noticed over the cut edges for the both roof eave and also the side lapping. And towards the surface, we also didn't notice any sign of the corrosion, the red rusting corrosion, except for those certain areas with the severe scratches and some stubborn soft stain. And in terms of color performance, I would say a minimal color change have been noticed compared to the original color sample panel. And this is very minimal the pickup, and also the water strip mark have been noticed over the external cladding materials, which also proving that the effectiveness of BlueScope clean technology in this mast hanger project. And in terms of workmanship, to always show the good practice by follow all the roof detailings provided by the roll form expert. For this mast hanger, the installer does really comply and also follow all the roof detailings which is provided by United Season, and try to avoid those soft staining, scratches, and overpainting activities on top of your external cladding materials. Yep. So I hope you're able to gain some insight from my sharing today. If you have any questions, please feel free to contact me afterward. Yep. So Jaiti, pass the floor back to you.
Thank you, Sok Ling. Thank you, Sok Ling. Such a depth case study been done. We were worried what is the outcome, but it looks all good after 12 years. I always believe having a good paint system, just like having a good foundation in makeup, yeah, it lasts longer, right? Sok Ling, thank you again for the time. I hope this presentation between Kawa combination with BlueScope have give some ideas for the audience to think about their project in the end of the day. Do you guys need more information? Please scan the barcode, the QR code at the screens, and do contact us anytime. In fact, for us, it's United Season at unitedseason.com at any time, mail at unitedseason.com. So for BlueScope, I think they have their good address over there. And I would like to say thank you, CIS, also have given us the opportunity to join this Architect Talk 2021. Hopefully, we can do it again. And as I said just now, fly safe, everyone. Thank you very much. See you again. Thank you.